Okay.
Are you collecting for G?
I will eventually.
And then have you ever teaching for E or
I will take that eventually. Yeah.
You did write it. I
I was doing it.
Don't worry. You have a whole bunch of years coming back around where you have the front page. You have the front page done only, and the rest is blank. Don't worry. I took care of you 4 out of 4. Oh wait, no, I took.
I didn't do that. I always do all my homework. That's Kate. And Graham.
I beg to differ. I took a look at that homework.
Always do my homework.
There wasn't anything.
I just didn't do the back page on this one. I didn't know for it.
Yeah, I didn't feel very that thing.
All right.
I did.
See, you're a good kid. You probably did
It's
some
just
nice
an
stuff.
off day.
Just be in the group.
Okay. So you have homework out, I hope.
Wait, when are we turning it in? Monday. I can't believe it. Monday. Okay.
Monday.
Well, I was thinking this. I do have to teach 5A, so we're going in it for unit. Don't worry, it won't mess you up. Well, it might mess your score up, but everyone else will be fine. I'm just joshing with you. If it does mess you up, don't worry. You can always retake a test. Next year, we're going to repeat the course. All right. I'm just kidding. Olivia, you won't repeat this course.
No.
What happened?
I never got there. Because a lot of people, like this class is like. Yeah, I would.
Are you going to start banging on people?
Yeah, shut up, Olivia.
I did have a bad one.
All right.
I didn't.
Lights off, party time.
I got one for 25.
Questions off of 4G.
No.
Because that is the review. Yeah. Say that one more time. The odd, even, or neither. So as far as the bonus question goes, that one?
Yeah, 17 and 9.
How about the fuse play? Okay. All right. So the question is, how can you identify even or odd functions or neither? All right. Graphically, if you had, say, a parabola and it shifted down, it shifts up or down on the. If you have a parabola that shifts up or down on the y-axis and it does not shift left or right, it is going to allow you to say you have an even function because you can fold it over the y-axis. Does that make sense when I say that? Okay. So is this first graph here, if I could draw really well, would you say it's even, odd, or neither?
Even.
Even. Everyone feel comfortable with that?
Yeah.
Does everyone understand why?
Yes.
Now, is this also an even function? Let's pretend that is. Here's your
Yes.
So up or down doesn't affect it. Shifting it up or down doesn't affect it. Okay? So that's your rule for even. Is that okay? I'm competing with a few voices. All right. An odd function would look something like this. So how you have to think of an odd as far as the picture goes is, can I take this right here, fold it over that line, and then once this folded over that line, if I fold it over this line, would it lie on top of that line? And that answer is yes on this one. So even has symmetry about the y-axis. Odd has symmetry about the y and x. So we call it just the origin. Now, the hard one is when you get students that get this problem. They're like, is it even or odd? And you're like, dude, it's a straight line. It's got to be one or the other. Clearly, is that one even or odd? Neither. It doesn't have any type of symmetry to it. I can't fold it over the y because this is going to go this way now. That didn't match up. I can't fold it this way and then flip it down. I mean, it could technically, if it went right through the origin, be considered an odd function. So if I had this, or if I had this, either one of those are odd functions, those red lines, because they are symmetric about the origin. And we'll just, I should have made this a different color. So the red or the blue are both odd functions because they are linear. They go right through the origin. So that would be considered your odd function as well if you wanted to deal with that. Okay? How do we feel so far?
Okay.
Okay, so then the other one that I think I say, oh, we have 2 bonus questions that deal with even or odd. That students are like, dude, I want to learn this. Like, well, you do really well on the bonus and you do crappy on everything else. It doesn't really help you all that much. Yeah, but it's bonus. Okay. All right. How can I tell? Oh, how can I tell if something is 1-to-1? And it's only graphically. Yeah. Slope is 1, maybe. That could definitely be one of the cases. How can I tell if it's 1-to-1? What's a pretty easy way when you look at a picture to see if it's 1-to-1? So you can tell if you have a function. You can tell if you have a function by the vertical line test. That tells me if I have a function or not, right?
Yeah.
But if I do the horizontal line test, and if it touches here, if it touches twice, it's not 1-to-1. Okay, so the vertical line test tells you if you have a function. Horizontal line test would tell you if you have a 1-to-1 function. And a 1-to-1 function can be even, a 1-to-1 can be odd. Okay, there's a variety of things that could happen. And then the bonus ones that just to think about. Let's say I have f at x is equal to 5x squared plus 7. Sound okay so far? All right, I want to test to see if this is an even function. So what I'm going to do is I'm going to take negative x and plug it in for my x value. Now this is the awkward part because you're looking at it going, what do you mean? Okay, so what am I plugging in for x from here to here? What's being plugged in for x? It's a negative x, agree? Yeah. Okay, so if I take that negative x, that's in parentheses, that's squared. So what's negative x times negative x? So negative x, or x squared, right? So if I do the math on this, look what I get. Is this the same as this?
Yeah.
That means it's an even function. Okay, does that make sense? If I want to see if I have an odd function, let's say I have f at x is equal to 5x to the third plus 7x. If I want to know if this is even or odd, all I'm going to do is this. I'm going to take negative x and plug it in. Bless you. So I have that. So then, again, I have this. I plug negative x in for what my original x value was. What is negative, negative, negative multiplied together? Negative. Agree? And then I get x times x times x is x to the third. Agree? Does everyone agree how I went from here to here?
Yes.
All right. What is positive 7 times negative x?
Negative 7x.
All right. So now, if all the signs throughout my entire equation are opposite from what they were above, that means it's odd. Are the signs all different? So I have a sign change here and here. I have a sign change here and here. I have both terms that have a sign change. That says right away, odd function. Okay? So you might see that as a bonus. Hint, hint. Yes, 2 problems. I don't know, but you're writing in your diary. Yeah.
Were you announcing last night?
I was.
How come you didn't call Hoover Pookie?
Well, when someone's sitting at the end of the bench guarding the water and tackling anyone who's trying to steal the water, it's kind of hard to announce anything about it. I'm sorry, what number?
37.
37 on G. Did I announce okay?
Yeah.
You're mediocre.
Whoa, dude.
Playing was mediocre.
Yeah.
Oh, wow.
So Cooper, why is it you only get playtime when we're on a running clock?
Okay, well. Let me explain.
The coaches.
I swear it's actually the coaches.
It's the coaches.
I was supposed to go in a lot earlier, but then they said all the seniors had to play because we knew we were going to kill them. I'm not even kidding you. Like, I was ready to talk about it.
I was so worried.
Why did not?
Like with that.
I mean, I actually saw like the tuba player out there with his tuba playing. You guys were reaching deep to pull anyone. Any volunteers want to play? All right. 37 says this, and this will be it. Okay. Solve the absolute value inequalities. Good so far? So this breaks into two problems all day long. What did I do? All right, we okay with that? So I have one equation that's the exact same. One equation where I change the signs inside here. Is that okay? Not yet. All I did is I just changed it on this side. I didn't bring it to the other side to flip it. All right. Shh. Some of you are talking too much. Okay. Shh. That's a subtle hint. All right. 2/3 x is greater than or equal to 24. So I'm going to multiply both sides by 3/2. So I get x is greater than or equal to 36. Is that okay? Shh. And then second problem. What? Subtract 9. Multiply both sides by negative 3/2. Cooper. Eyes up here, Gypsy. All right. So I get negative 18/2, which is negative 9. All right, so these inequalities are good to go. Let's take a look at where it looks like on the number line. So I'd have negative 9 here. I'd have positive 36 over here. I'd have 0 somewhere closer to negative 9 than I would elsewise. Am I really looking for the critical value? I guess I could find it if I needed to. 9. Yeah, set the what's in the parentheses or the absolute value is equal to 0. All right. So this is a solid dot going this way. And then I have a solid dot going this way. All right, so where is this going? Yep, and it's the negative one. That's going to positive infinity. So now to write the interval notation, I'm going to go negative infinity to negative 9, square bracket. I guess you should put the word or because or things go either way. If you forget to put or, I'm not all that worried about that. You can spell a 2-letter word. Okay, and then it goes from 36 to infinity. Done. Cool? All right. So, hang on. Talk about this. So, I want to offer this to you. If you need any help on any of these problems on the review, I'm not going to collect the 4G review. I'm not going to collect it today. Okay? I need you, if you need help on any of those problems, do me a favor. Take a picture of it and text it to me.
No way. Alright, 2 a.m. 2 a.m.
Well, I might not answer at 2 a.m. So, if you come across something on that, if you come across something on your homework this weekend, now, I will tell you there are certain times that I won't respond to your text. Okay? So tonight, I'm good up until probably 10 o'clock. Okay, sorry. I got a busy week. I'll probably go to bed early. Tomorrow, I'm good all day if you have questions. I got church between about 4:30 and 6:30, so I won't respond to it during the sermon. Mission Hills.
You go to Mission Hills?
Yes.
I used to go there.
Yeah?
I was there when it was
Yeah, wait,
first
what?
made or whatever.
Oh, the new building?
Me too.
The old one in Greenwood Village?
The new one.
Yeah.
Granny went to Mission Hills.
That's weird.
Me too.
So, sorry, you guys asked.
No, I'm not.
You gonna see G?
On Saturday night.
The church grew so big that they asked some of the congregation if they'd be willing to go to service on Saturday night. That's why. I mean, there's about 3,000 people that attend on a weekend. It's a big church.
Do you like him?
Do I?
Don't just save yourself and
Okay.
walk away.
All right. So, is that a deal? So, ladies and gentlemen, listen. The reason you have to text the picture of your problem is I don't take my math book home with me. I'm sorry. I get here early on the weekends, or early on during the week to grade, okay? So I don't take things home with me on the weekend. I look at my home as my home, but I know we have a test. I know some of you are like going, oh my gosh, I'm panicking. So take a picture of it. I will then rework out the problem. If there's like extensive directions to the problem, make sure you put in the text. You know, we need to make sure we have this in this form or that form. So take a picture of that problem. I'll work it out for you. I'll take a picture, send it back to you at some point. Okay, if you're that kid who's up till 3:30 in the morning, if you're at that cool poetry reading late at night with all your friends, I don't need pictures of you. I don't need pictures of your friends. I don't need you to send me a text going, dude, what's up, stirrup? Okay? So, deal? All right. So I would like to, if you have anything to turn in that is not 4G, is the stapler gone around? So I do not want no 4G. Anything else that you might need to turn in, please wait for the stapler to get to you, staple it, and then I will need it in this orange folder, which is open on my desk here, eventually. Yeah.
Oh, let me get that staple.
You're taking for full credit, right?
They might say 0 in there right now missing, but it's just because I haven't graded it yet. I'm a fast grader, but I can't go that fast.
It's dry. Don't touch it. I think I'm all caught up.
All right. So, I can't count. My gosh, I am just a silly dude. I'm sorry. All right. All right. Our next unit that we're starting today, don't worry, it's not going to goof you up because a lot of the transformation rules, actually all the transformation rules that go with them are the exact same. Good so far? So again, ladies and gentlemen, if you are submitting anything that is not 4G, just put it in the orange folder. Make sure you wave to the camera as you go by.
Extra. Or
Extra?
homework time. Homework time.
Hannah, where you at? I heard a yeah. Olivia? Huh? Yeah. All right. We'll go put these in the safe spot. Yeah. Where you guys going? All right. So, quadratics. Sit, would you? Quadratics. Places you will see quadratics applied to real life. Okay? Because you're like, when are we going to have to use this? If you've ever ridden in a car, the braking system on a car works by a quadratic. Okay? Your braking distance, your stopping distance works as a quadratic. So your faster you go, the further it takes you to stop. Okay? Now you're like, well, duh, but it's not a linear fashion. If you've used your brakes on your bicycle, it's the same thing. Braking distance is a quadratic. Things that free fall act as a quadratic. Okay? Things you throw act as a quadratic. Things you throw up, not barf, but like toss in the air. Things that you throw down, things that you throw sideways, those all act as a quadratic. Okay? Nope, because it comes out of your nose. All right. So here we go. So down 4, yes? We good?
Yep.
All right. Flip over y. Oh my gosh, that could have been any less clear. Or wait, flip over x-axis. Sorry about that. And left 3. Agree? Gentlemen, over there on the far side, on the north side of my wall. Get out of my seat. You're taking too much time.
It's Grant. We're sorry.
So this has a stretch in the vertical direction of 2. So it grows twice as fast. And it goes right 4. Shout out. Here we go. What's this one do? Right 1. Up 7. All right. This one is a fat graph. Okay. So it has a vertical compression is what it's called. So it's a vertical compression. If it's, yeah. So if it's a fraction between 0 and 1, it's a compression. But if you had like 5/3, that's bigger than 1, so it's still a stretch. All right. Best way to look at stretches, we'll get to it in a little bit, is you pattern graph it. You go up 1, right 2, up 1, right 2 on this one. That would make it fatter. And then it shifts up 1. And then what does this do? Yeah, so flip over or reflect over x-axis and down 5. Agree? Cool. Everyone happy? As you might see, these are the exact same rules that apply to absolute value graphs as these graphs. Okay? Can I move on?
Yeah.
Oops, I went too many. I apologize. All right, so the axis of symmetry is this imaginary line that you acts as a mirror. So this line here, this dotted line, is called the axis of symmetry. It's very easy to find. The axis of symmetry is, so if you knew what your vertex was, your vertex is actually HK. So that's your vertex. Okay, and we'll get to what HK means. But x is equal to h is the vertical line that gives you the axis of symmetry. Okay, and the axis of symmetry is just the vertical line that you can shift your graph over. Sorry, I want to sit. I had a long day yesterday. We good? So the nice thing about when you flip things over the parabola, it just folds over on top of itself. I don't know why we put this much information on this problem. Vertex parabola, okay, we'll get to it better than 14 feet. All right, what are the features of the parent graph for a quadratic function? So the most basic quadratic function you can graph is y or a function at x equals x squared. Okay? So the great thing about a parabola, it graphs as pattern graphing. So I go right 1 up 1, right 1 up 3, right 1 up 5, left one up 1, left one up 3, left one up 5. Now some students say, why does it grow by the odd numbers? I don't know if you knew this, but the odd numbers, if you have perfect square numbers, the difference between perfect square numbers is your odd numbers. So think about it. From 0 to 1, which are both perfect squares, you have a distance of 1, correct? Between 1 and 2, or so the 1 squared and 2 squared is 1 and 4. What's the distance there? 3. The distance from 2 squared to 3 squared, which is 4 and 9, is 5. So pattern graphing works really well. This opens up. The line of symmetry is x equals 0. So it would be this line right here, which is our y-axis. And if I could draw straight, I'd be a much better person. This has a y-intercept that happens to be the origin. And it has an x-intercept that also happens to be an origin because it happens at 0, 0 as far as the vertex. I guess I should put vertex as this. Is that okay?
Yeah.
So again, I truly feel that parabolas are something that you will see the most of as far as mathematical terms that you will start applying to. You see linear things all day long, but maybe you'll start thinking a little bit about parabolas. Or going, dude, why did it take us so long to stop? Well, because for every mile an hour you stop, it takes an extra 5 feet per mile per hour per car to stop. So, bad stuff. All right, so correctly locate the graph. So this one did what? Did it shift right or left? Right? Did it shift up or down?
Up.
Okay, does it open up or down?
Up.
Okay, so which one of the graphs? The black, the green, the red, or the blue? Green? Okay, so this goes with the green graph. Is that okay? What about this one? Does it shift right or left? Doesn't. Does it shift up or down? Down. Does it, or wait, it shifts up, excuse me. 8. And does it open up or down?
Down.
So which one is this? Purplish? Is that all right so far?
Yeah.
All right. And then this one. It shifts left 1. Does it open up or down? Down. So that's that one right there. Ooh, we tried to trick you on this one. Okay? So, obviously you can use your process of elimination to say, hey, this is the red line, but let's see why it's the red line. It shifts down 4. Is everyone okay with that shifting down 4? Yes. So this right here, if I go this, if I do this, set that equal to 0, it shifts right 3, which this one indeed did. Okay? Is there any questions on how that one would go when we're just taking a look at it? And again, we're just looking at the shifting right, left, the shifting up, down, the shifting open, up, open, down. We're going to start looking at some of the pattern graphing, which is pretty easy to figure out. All right, can I move on?
Yes.
Beautiful. All parabolas either have a max value or a min value. Okay? It's a max if your parabola opens down. Okay, you have a max value up on top. It's a min value if your parabola opens up. Okay, the max and the min value is the y value of your vertex. So if you have a vertex, if you have a parabola that opens up and you have a vertex of 5, 10, your max value is 10. Okay, it's the y component. So how do you know which will apply when given the equation only? Okay? Well, you know this one's going to open up. So is it, because it's positive, so if the parabola opens up, is our vertex at a minimum or a maximum? It's at a minimum. Does that make sense? Because this is what this parabola would look like. My lowest point would be a minimum. My lowest y component point of my vertex is my minimum. What about this problem right here, letter B? Does it open up or down? Down. So do we have a max or a min? We have a min, or a max, excuse me. That top value there, my y component there is a maximum value. What about this one? Does it open up or down? Up. So it opens up. Do we have a max or a min? We have a min. Again, our y component of my vertex will dictate the maximum or minimum, depending on if it opens up or down. And then this last one opens downward. So do we have a max or a min? We have a max. Okay, the max. So your highest point of your y component is your vertex. Okay, the y component of your vertex is your maximum value or your minimum value. We good?
Yeah, we're good.
Good on time so far?
Yeah, we won't.
Cool. Which, for each of the functions below, where will the vertex be located? And then is the vertex a min or a max? Okay, does this one open up or down? Okay, so it's an up. What's my vertex got to be on this one? Close. 0, 5. So that would give us a minimum value because it's opening up. Does that make sense? The vertex is the lowest part, lowest point. Yeah. What's the spank and tickle game you guys got going on over there? I'm serious, man. You guys are playing spank and tickle all period. I love that game. Spank and tickle. The game y'all are playing is spank and tickle. You all figured it out. All right. Cut it out over there, would you? All right. Does this parabola open up or down? Down. What is my vertex? What do we got?
0, 7.
0, -7. Okay? If it opens down, if it does this, is this a max or a min? Max. Okay, and again, I'm pointing to the y component. What about this one? Open up or down? Down. What's my vertex? 0, 20. Is the y component a max? Cool. And then last problem. Does it open up or down? Up. Vertex is? 0, -15. So if the parabola opens up, or we have a max or a min? So that is a what? Min? The bottom, right?
Why? Because it opens down. Oh.
Yeah. It's max if it's at the top. Min if it's at the bottom.
Any questions so far? You looking good? Yeah, baby. All right. Ordered pairs. What is true about all y-intercepts? All y-intercepts are ordered pairs, so I guess that's what we're trying to get you to realize. So 0, something is a y-intercept. Y-intercept is your vertical line, correct? So for each of the following equations, identify the vertex, the x-intercepts, or state none, if there isn't any, and then the y-intercepts. Okay. So first problem. Identify the vertex. 0, 4. Agreed? That's also the y-intercept. Think about it. 0, 4. I don't go right or left at all. I just go up 4. Right? This is my y-intercept. It's also my vertex. So they are one and the same. How do we figure out where this crosses the x-axis? How would I solve that problem right there? Plug in the 0 to get the y-axis. What about the x-axis? How do I solve this? How do I solve the blue?
Oh, don't you know that you make it x squared equals
Yep. So if I take the square root of this, x is equal to, let's see how well your Algebra 1 teacher thought. I have, if I solve x squared equals -4, I take the square root of both sides. If you take the square root of both sides, you have two answers. You have a positive and negative component, but I have a positive and negative 2i. 2i? What is 2i? Anyone? Yeah. Right. So, if you see an answer that has I as part of it, I is not a variable. I stands for an imaginary number. An imaginary number is a number that is part of a number system called the imaginary number system. It's part of the huge complex number system, which is the name of it. Okay? If you have plus or minus 2i, this means our graph. If we graph this graph, it looks like this. If this is my xy axis, it does this. Does that parabola cross the x-axis? No. Okay? So imaginary solutions on a real number line, as far as your x-axis goes, doesn't exist. Okay? Do we need to know about the 2i or the I value yet? Well, it's just a preview of what's to come. All right. What about problem number 2? Problem number 2. What's my vertex? 0, comma.
-4.
Not you don't have to square anything.
-2.
-2. Why is it -2 and not +2? What's that? So this negative has nothing to do with it right there. The reason it's a -2, if it shifts right or left, it always shifts opposite of what you would think if it's grouped in that. Okay? Same idea with absolute values. So because I have x plus 2, that means that this parabola is shifted left 2 to get the vertex. This is also the y-intercept. And then let's see if we can solve. All right, I'm going to multiply both sides by negative. Take the square root. Square root of 0 is 0, right?
Yep.
Excuse me, I shifted it the right way. I put it in the wrong spot. That's -2, comma 0. Y-intercept. I need to figure out the y-intercept. Okay, hang on, I goofed up on this one. Hang on. Shh. It is, that's the negative right here. Okay, this is -2, 0 because that shifted. It didn't go up or down at all. That's also where it crosses the x-axis. How do I know where this is going to cross? This parabola opens downward, right? Because of that? So if it opens down and it shifted left 2 and opens down, how do I find where it crosses the y-axis? Okay? If this is the x-axis like this, and this is what the parabola does. It comes up, hits, comes down. Got it? Does that make sense? Is it going to cross the y-axis down more in the negative region, or is it going back in the positive? All right, ready? Here's what we're going to find negative. Ready? Ready?
Yep.
2 squared.
4. -4.
So 0, -4 is where it crosses the y-axis. Okay? The y-intercept is 0, -4. All right? 0, -4. Get a 4 in there. All right, almost done. I got time. Okay, so the vertex here is going to be 4, 0. The parabola opens up and it's a little fatter, right? Where does it cross my y-intercept? Well, what's 4 squared? 16. 16. 4 times 4 is 16. 16 times half is what? Where does this cross the x-axis? At 4, 0. That's also the crossing. The x-intercept and the vertex are one and the same. Some of you are packing up, man. It's not time to go. We still got 3.
Oh, I'm grinding for those 3 minutes.
All right. All right. Vertex. 0, -8. Where does it cross the y-axis? Same spot. Agree?
Yep.
Where does it cross the x-axis? I don't know. Add 8. Divide by 2. Take the square root. So that gives me plus or minus 2. Where does it cross the x-axis? At 2, 0, and at negative 2, 0. Okay, you're solving it. It's just algebra 1, that's all you're doing. This one, we have a vertex at 0, 9. Where does it cross the x or the y-axis? Same spot. Solve where it crosses the x-axis. Multiply both sides by negative. X squared equals 9. So at 3, 0, and at negative 3, 0. Thank God I'm done there. Right? That was the last slide?
Yeah.
All right, so test Monday. Test Monday. 4G is due Monday. 4G is due Monday. Just fold the corners. All right. And then for due, this will be due Tuesday. Tuesday, 5A is due Tuesday. Got it? If you have a question on the review, what do you need to do? Text me what?
I got my
A picture of it. Cool? Get out of here, guys and girls. Take care of one another. Have a great weekend.
Thank you so much.